A lot of you are still on your balancing of equations, so for numbers 2 and 3 you don't need to write them. We'll just talk about them, save some time. Alright, so while they're filling that out, what do you need tomorrow in order to participate in your Purple Study Guide? I'm not looking for 100% completion, I'm looking for what kind of progress have you made. And that's only to help you all. Again, the final on Friday is multiple choice. We're currently changing some questions. And it pretty much covers everything we've talked about in chemical reaction. And then are you going to do B as well?
I'll do B.
Yeah, do B. Take a look. Also at the bottom, I put the name of somebody that was born on this day. See if you can remember where that name comes from. And it's pronounced Richter. Richter. Who is that?
He created the Richter scale.
He did, which is really important for women in California. Measure triplet. How crazy they are. All right, thanks, guys. Are you fixing your mistakes?
Yes.
Oh, whoa. Alrighty, this looks good. I think we could actually reduce B. So you're on the right track, but maybe you have too many atoms, which is not a huge deal. So looking at A, raise your hand if you all agree with A as the answer, and that it's single replacement. That would be correct. And then B, how can we reduce that? What'd you get?
I got 0 for the first one.
Okay.
Yeah, like that.
Alright.
And then I got 2 for the O2.
Okay.
And I got none for that one, yeah.
Okay.
And then 2 for the H2O.
Yep. A lot like, if you recall fractions, you had to put them in simplest form. So that's a common mistake. I still would have counted it, right? Because it technically balances out. Now, looking at number 2, how does temperature affect reactions? More heat is faster. Absolutely. And then what about if we make it cold?
Well, for B,
Yeah.
you wouldn't put 2 in front of O2 because otherwise it would be balanced on the other side.
So what do we do wrong?
You wouldn't put a coefficient there.
Let me check it out.
Huh.
1 carbon, 4 hydrogen, 2 times 2, 4 hydrogen, 2 times 2, 4 oxygen, 2 oxygen, 2 oxygen.
Okay, never mind.
That's all right. Don't worry. You just got to go through and recount it. They're confusing at times. And then again, guys, really quickly, if you make something colder, the reaction slows down. And number 3 is share. That's the key word, share. Alrighty. Any questions on these? Any questions about the test, about the study guide, about the loop, etc.? Please bring your own device. And if we could please clear the desks. Other than this. And thank you, Cole, for getting your name on there. Do me a favor, and you're on the side that has all of the writing at the top. Do not jump ahead. What was the key word yesterday that we needed to focus on in our groups? Elaborate. Oh yes. So please do not go ahead. And if you would like to say you're an expert on these concepts, don't go ahead. We'd rather not do that. So I'm going to leave that up there so I don't forget to do it with you all. But here we are today. We're at balancing equations. And just tell each other really quickly, what does the law of conservation of matter state? If we could all just tell that really quickly to each other, and we'll get going with this activity. Raise your hand if you'd like to share the answer with the class. Yes, please.
Matter cannot be created nor destroyed.
You are absolutely right. So now if we get very technical, what does that mean in terms of the number of atoms on both the left and right side of an equation? Yes. Same. Maybe if 10 atoms go in, then 10 atoms come out. So that's what we're doing today. We're going to take that one step further, just like yesterday we reviewed types of equations. Today we're going to go back and review balancing. And I've actually had students come to me and say, thank you. I get it now after doing this. Because they're not just looking at numbers and letters. It's very visual. there's a small sample of what will be in these envelopes. It's very visual. So you might be able to just look at them and balance them. Okay, we're going to go over instructions. There's a lot, so you pay attention. We're going to do the group activity, and based on earlier periods, we might not get to follow-up questions as a class. But if you flip your papers over, you're going to want to know those questions. Intense. So, let's get going. On your papers, read the instructions, the very first paragraph. As you all look up here when you're done, do me a favor and just kind of give your neighbor cliff notes as to what we're doing today. Real quick rundown of what's going to happen today. We're just starting. So my first question for table 2, what's in the envelopes? It's not money. Molecules are in the envelopes. Okay? Molecules. They're very colorful and very visual. Basically, let's pretend that what you see on the board is an envelope that we've opened. That's exactly what you're doing today. So here is, on the board, demo number 1. You wouldn't get this because it's the demo. You basically, as a group, and you're going to have different jobs based on your sheet color, you get these all out. These are all your molecules. And you're going to lay them out on your table as a chemical equation. Some of you are like, I get it, though. Yeah, but practice makes perfect. And it's a chance for us to all help each other out one last time before the test. So, let's go ahead and read the steps. That's the bigger paragraph. It's in the middle of your paper. Raise your hand if you already read that. Okay, good. All right, let's read the steps paragraph. All right, let's do a quick rundown together, guys. Step 1 is to please make sure you have the right envelope. Obviously, you'll start with your table number envelope, and then it's going to get a little bit crazy. Some of these are quick, some take more time. So that's when the jobs come in. Because if you're sitting in a blue seat, you got to communicate, figure out, hey, do any of you guys need this number envelope? Nope? All right, bring it back up here. So please make sure that the envelope number matches the box number on your papers. Use the top of your table, so just make yourself an equation across the top. That's where yellow and green come in. It's kind of a big job. There's like about 20 cards in each envelope. So you got to work together, yellow and green. Whoops, sorry. Working on your own. I'm just kidding. You got to spread out those cards. Count the atoms first. Just like any balancing, you got to count what you got when you start. And then you got to add more molecules. How many molecules are in each kit? There's about, well, there's 20 cards. There's little arrows and stuff. But you're going to start with 4 of each molecule. You might use it. You might not. We will find out. And then you go back and add your coefficients. Then you figure out what type it is. And then you just switch those envelopes. Okay? Let's check our jobs one last time. Check your seat color, check your table number, and figure out what you're doing today. Please. Alright, we're good? Worked out really well all day. Please, Lucy, communicate. Don't let those envelopes pile up. You either check around you or you bring them up here. Alright, guys. Let's do a demo together. Demo number 1 in your paper. Let's all fill that out. We're going to do this together. There we go. So I open up the envelope, and if I'm in the yellow or green seats, I lay out the equation across the top, and then I start counting my atoms. So here I've got, well, first of all, what are my coefficients right now on the paper? What's that? There's nothing there, which means that it's number 1, okay? So I have 1 molecule of each. That's what I lay out across the table if I were in the green or yellow seat. Let's look at this really quick. We can either count atoms, or maybe we're very quick with visual, and see, is it balanced? So just think on your own. Figure out if it's balanced, and then we'll go from there. Raise your hand if it is balanced. Okay, raise your hand if it's unbalanced. Alright, so now tell me what's the first thing you would do to get this balance?
Radical coefficients to and from the H2.
We got our envelopes full of molecules though. We're not doing coefficients just yet. Yes?
How many of them?
Yeah, so we counted there's definitely an imbalance. What would you do with your envelope full of molecules? What do we need to do?
Put them together?
Maybe. I got a nice assortment of more water molecules, more oxygen molecules, more hydrogen peroxide molecules. So what would you do, guys? What would you do to make this balance? Let's back up. How many reds on the left? How many on the right?
3.
Well, there's an imbalance. So let's get more reds on the left. Just like that. Now, what do I do to the right side? I need to add another red over here. And the only way to do that, because I can't take apart molecules, is by doing that. All right, so our reds look good. How about our yellows?
Yeah.
All right. Now is where the coefficients come in, so please walk me through those coefficients.
To and from the hydrogen peroxide.
Okay.
To and from the water.
Yep.
And nothing in front
For those of you that don't like to leave blank spaces, you can put a 1. Doesn't matter, but that's what you're doing right now. 2, 2, and 1. And that's all there is to it. Red, what's your job?
All the molecules back in the group.
Just figure there's about 200 loose pieces in this room when we get started. So far, we've not lost any. 81, but that's okay. Nice. So red, you make sure it's all put back in the envelope, and then blue, you come in and you got to communicate, get that envelope exchanged. Are there any questions? Because if you are sitting and waiting for an envelope, go ahead and flip your paper over, guys. You have 2 options. You can start working on questions as a group, which is fine. Or you can come up with a smartboard, and there's about 28 more to choose from on the smartboard. You choose whichever ones you want. And you work as a group, and you balance them, and you count coefficients and all that. So that's what the back of the paper is for. Now, are there any questions? Okay. If you come on up, remember tables 1, 2, 3, 4, 5, 6, 7, 8. Get the matching envelope, and you may get started. Number 10 is a bonus, just in case you're still waiting. I will walk around to help you and to check answers. Need help on this one? Or is it done? You got a lot of oxygen here, but not a lot.
So we have to put another.
And you got 4 hydrogens, 2 carbons, 2 carbons.
And there's 2 right there. Okay, so if we did 2 and then 3 right there.
And then just plain hydrogen.
You've got 2 and 2 yellow. Purples are good, blues are good. Let's count the reds.
Is that carbon? So then we have I know. Basically 0. Oh, so it's to add another and the reaction. But we need to have 5
Alright, we're all set.
Yeah, but you know, like Just as a reminder of what to do while you're waiting, I've got that up on the screen.
I think we're only supposed to.
Yeah, all you're doing, like if right now there's a coefficient of 1, you're just changing coefficients. You can't change molecules. You can't write part molecules. But you have to copy down whatever equation you do. Hey, listen, we've got a group at the smartboard. If you want to follow along, you can fill out some of the ones on the back of your paper.
Number 5. Number D.
What about?
Remember, it was nothing. Reaction. What was the reaction? Single laser. What is it? Wait, what was the
Just drag them.
Two C No.
We got 2 of them.
No, I don't. Yes.
We've got a timer going, and that's when we're going to stop to put the cards away.
Oh wait, no. I thought that.
I thought the one was grabbing.
Hey, do you guys want to practice the 7th grade? Figure I've got more.
Why? Which one is that?
Anybody want to give us 7th Practice on. Did any of you guys want to come to 7th period practice? Anybody want to come to 7th period practice?
There's no add-on.
Table 5, you got all that written down? Table 5, you're good?
Oh, this is the correct one.
When they, yeah, you're good. Wait, what?
Okay.
They want to do one of them.
Which one's that?
Table 4, there's a bunch. You can go to all that. Your choice. Oh, that one's
You have to put that one on.
So,
2-minute warning, guys. 2-minute warning.
No, it's not. You should just grab it. There's one end on the left.
Anybody have number 6? Finishing? Done? Done.
Number 8 is balance. Yeah.
we need number 9.
What are you doing? No, wait, you're gonna go to break. No, it's not. One of those. Yeah. Wait, no, we can't do that.
Oh,
You did it.
now it's 3. And now it's in 30 seconds we will be putting all of the cards back. We will be putting, listen, all of the envelopes back on this front counter. Okay, take a look at the next second molecule. Again, if you could all do me a favor and bring the envelopes up for the next class, that would be great. Don't forget, blue and red, you're kind of in charge of all that cleanup there. And then before you leave, if we could flip that paper over and talk about some of those items on the back, please. We're going to look at some of those questions together. Do I have all the cards? Just see one more envelope. Alright guys, on the back of that paper, let's do a very quick rundown before we leave. Earlier we defined the law of conservation of matter, so please know what that is. It is a test question coming up. And then number 2, I think I mentioned, but basically you can only change coefficients, and I think maybe you've realized why, but who can quickly tell me why do we only change coefficients? Not the little numbers. Yes? Yeah, so if you go to like H2O and add a little 2 to that O to make it H2O2, it's a whole new chemical. So do not touch subscripts. Coefficients, so that's what you did. If you had one card, your coefficient was 1, and then so on and so on. Coefficients are the only thing. Who can tell me what a balanced equation is? What does that mean? Like, we've been doing it, that's pretty clear, but what does that mean?
It's when the equation has the same number of atoms on the left side of the equation as the right side.
It's simply a quantity, so it means that what's on the left is the same as what's on the right. Perfect. And then, guys, that's review on so many different times. A and B, it's like what's on the left, what's on the right, products versus reactants. Please understand those. Number 5, we need to know what happens to chemical bonds. Basically, whatever happened to those molecules on the left to make them turn into the molecules on the right, that's going to be on a test someday, or the one on Friday. What happens to atoms? If you look at your little cards, the atoms didn't come apart. The atoms just got taken apart from other atoms. And then what does the subscript indicate? It just means the number of elements. So, guys, try and finish this tonight, please. I'll make a new one Friday.